This is the story of one of the most influential buildings of the 20th century, and how it was virtually uninhabitable. In 1928, the wealthy Savoy family hired Le Corbusier, the rising star of modern architecture, to design a weekend retreat just outside of Paris. What they got was a Villa Savoy, a futuristic white box radically different from anything built at the time. Le Corbusier boldly eliminated all traditional ornamentation, no pitched roofs with decorative overhangs, no cornices above the openings, no overhanging parapet copings. Instead of thick, load-bearing masonry walls, he opted for a single layer of brick covered with white plaster, allowing him to elevate his pristine white box on impossibly thin concrete columns. He positioned his revolutionary design at the very top of a hill away from all trees, ensuring his architectural statement would be visible to all. This building finally liberated architects from decorations and ornaments. Modernism was born. There was just one small problem. The building leaked horribly. Soon after completion, water began pouring through those sleek ribbon windows. It dripped through ceilings, walls blistered with mold. Madame Savoy's young son fell ill because of these conditions, and the family refused to live in their architectural masterpiece full-time. They eventually took the rising star of architecture to court. Villa Savoy was inhabited for less than 7 years and spent most of its century as a museum of itself and a cautionary tale for building scientists. As it turns out, all those cornices, copings, sills, overhanging roofs, and gutters weren't just decorations. They had a crucial purpose. They were responsible for what Dr. John Straub calls job number 1, managing rainwater, which, according to him, is only preceded by job number 0, keeping the facades structurally sound. In his research paper on rain control in buildings and subsequent lectures, Professor Straub outlines how facades should be designed to manage rainwater by utilizing the 3Ds method. And the 3Ds are deflection, drainage, drying. Those cornices, overhangs, sills, and plinths that were so common in Beaux-Arts, Classical, and Gothic architecture served the vital purpose of shedding water away from the facades as quickly as possible. The ornamentation of these elements was not purely decorative. The geometry of these decorations also directed water away from vulnerable areas. Even gargoyles weren't primarily spiritual. Their main purpose wasn't warding off demons, but projecting rainwater from roofs as far from the facade surface as possible. Who knew that medieval builders were actually practicing advanced water management engineering? Research has demonstrated that the geometry of roofs and overhangs directly correlates with potential leakages in facades directly below them. And the trees and location of the buildings has significant impact on wind speed and by extension correlate with the deposition of wind-driven rain on the facade. Despite Villa Savoy being a masterclass in what not to do when designing a facade, architects fell in love with the aesthetics. They've spent the last century methodically removing all visible water management features from buildings. But the job number 1, managing rainwater, still must be done, so facade engineers retreated inside of the external walls, designing ingenious solutions ranging from drained and ventilated cavities to complex joint interfaces in curtain wall and precast concrete facades. The traditional cornice above windows, designed to shed water away, has transformed into a deflector channel hidden behind the flat, seamless surface of rendered insulation, invisibly directing moisture away within the cavity. Protruding masonry sills are now layers of overlapping membranes and elaborate pressed aluminum flashings. Thick masonry walls have given way to perfectly flat glass surfaces with pencil-thin joints. All the water management happens within these tiny spaces through the elaborate labyrinth of aluminum and polyamide extrusions. Overhanging gutters with gargoyles have been replaced with flat fascias with barely visible overflow pipes. However, all these innovations came at a cost. The newly formed cavities became prime real estate for mice, rats, and particularly discerning pigeons looking for luxury accommodation. Engineers had to design additional features to mitigate the risk of infestation. Anti-pigeon devices and insect facade cavity meshes are now legitimate product categories in building supply catalogs. The voids within modern facades created risk of interstitial condensation and mold growth. This led to elaborate assembly strategies involving ventilated cavities, specialized insulating materials, thermal breaks, and membranes, which in turn created risks of rapid fire and smoke propagation. So engineers developed even more elaborate methods of mitigating these risks, introducing increasingly innovative materials such as intumescent strips and pre-compressed mineral wool slabs covered in combustible mesh, keeping them in tension in order to expand when exposed to fire. It is almost as if those decorative traditional details served multiple crucial functions. Who could have possibly guessed? There is no one better to explain water management in building envelopes than Dr. Straub himself. Professor Straub has kindly allowed us to use his lectures on deflection and drainage that he recorded for his students at the University of Waterloo. We have expanded on these lectures with interactive 3D details, multiple choice tests, and third lecture prepared by the Institute for Architectural Science and Technology, and created an online course on rainwater management in facade design. The course is free and available to all. Dr. Straub is a renowned building scientist who masterfully bridges academic research with practical construction knowledge. As a principal at RDH Building Science and faculty member at the University of Waterloo, he's become famous for his no-nonsense, sometimes humorous approach to explaining complex building physics concepts. His pioneering work on moisture management and building enclosures has transformed how we think about facade design, earning him tremendous respect across architecture, engineering, and construction industries. The course's interactive 3D models are based on the case studies from the Facade Intelligence platform. These models showcase how the concepts of deflection and drainage manifest in modern facade assemblies, including masonry veneers, insulated render systems, precast concrete, and curtain wall facades. In the third lecture, we explore how rainwater management is addressed in best practice guidance in the United Kingdom. There is certainly no shortage of rain in our corner of the world, and by extension, no shortage of leaky facades. In the UK, when a new building leaks, it is generally insurers and warranty providers who pay the bill. Understandably, they are rather motivated to avoid this expense. So tapping into Britain's world-class strategic stockpile of miserable weather, housing warranty providers and insurers have developed one of the most comprehensive guidances on facade detailing when it comes to rainwater management, informed by decades of costly post-completion repairs. In the third lecture, I'll guide you through how the rainwater management concepts so clearly explained by Professor Straub are translated into housing warranty providers' best practice details here in Britain. You might be surprised how globally relevant these details are for the building envelopes. You will see how the rain splashback introduced by Professor Straub determines dam-proof course dimensions prescribed by warranty provider standards. You'll discover how wind speed maps and cladding joint configurations correlate to cladding size and brick geometry. You will find yourself counting weep holes in brick lintels above windows. And yes, you will be looking for modern-day gargoyles hidden in every compliant balcony fascia. The multiple choice questions for this course were carefully selected from other courses offered by IAST and provide additional insights into the topic. We design our questions not just to test knowledge, but to introduce new material, so don't skip them. The course concludes with a short 20-minute examination should you wish to receive a certificate of completion and earn continuous professional development hours towards your annual quota. In pursuit of minimalist aesthetics, architects systematically eliminated all external features that traditionally managed water in building surfaces. Facade engineers had to develop different ways to manage water within the facades themselves. And in pursuit of function, they've created miniaturized temples with elaborate ornaments and even fountains that only they can see and appreciate, hidden away behind sterile modernist flat surfaces. Join me and Professor Straub on this journey into water management in building envelopes, and you'll learn to see and appreciate the invisible temple hidden behind modern facades.